All right, let's jump right in. We're going to tackle a huge question today, one that sits right at the heart of our digital lives. How do you really know if what you're looking at is, well, real and unchanged? We're going to dig into this idea called Codatta, which has a pretty wild solution for locking the truth in place. So yeah, let's get into it.
No, really, just stop and think about that for a second. Every single day, you're opening files, looking up photos, trusting all this data. But can you say with 100% certainty that the document on your screen is the original one? That it hasn't been tweaked, even in some tiny, impossible-to-see way? This isn't some paranoid fantasy. This doubt is actually built right into the way we store pretty much everything.
And that right there, that's the heart of the problem. You see, almost every system we rely on, I'm talking cloud storage, huge company servers, you name it, they're all designed to store files that can be changed. That's what they do. They're meant to be edited, overwritten, replaced, and a lot of the time, there's no obvious sign that the original was ever even there. It's a whole system built on, well, impermanence. So what you're looking at here are two totally different ways of thinking about data. On one side, you have most systems, right? They're all about storing files that can be changed. But Coddatta's approach, it's something else entirely. It's not about managing files that can be edited. It's about locking the truth in place the second it's created. This isn't just an upgrade. It's a complete paradigm shift.
Okay, so what does locking the truth actually mean? I mean, this isn't just about clicking read only on a file. It's about creating a system where a piece of data's identity is permanent, completely tied to the data itself. So, how in the world does that work?
And this quote just nails it, doesn't it? The moment data enters the system, it's not just sitting there waiting. It gets actively processed. It's encrypted for privacy, anchored so it can't disappear, and, this is the key, it's given a permanent identity that it can never ever shake. It's like having a security detail from the very first step.
Now, that permanent identity thing, that is the real secret sauce here. The system creates what is basically a unique, unforgeable fingerprint for every single piece of data. So let's pop the hood and see exactly how this thing is made.
It all happens in 3 clear steps. First up, encryption. Before your data goes anywhere, it's scrambled into gibberish, which keeps it private. Step 2, the system creates that special fingerprint we were talking about. And third, and this is so important, that fingerprint gets anchored to decentralized networks. What that really means is it's recorded across a ton of independent computers, so no single person or company can ever go in and change it or delete it.
Okay, so let's get a little technical for a second. What is this fingerprint? Well, it's a unique identifier made by mashing two really powerful crypto things together. A content hash, which is just a special code generated from the data itself, and something called a content identifier, or a CID. You put those two together, and boom, you get a digital signature that belongs only to that exact piece of content.
And this illustrates it perfectly. Honestly, it's the best analogy. Think about it like a DNA code. Your DNA is the fundamental, unique code that makes you, you. Well, this fingerprint is the unchangeable code that defines a piece of data. It becomes its very identity.
And this is the big shift. This is the crucial point. Your trust is no longer in a company's promise or some server in a basement somewhere. The source of truth becomes the math itself, that unchangeable, verifiable fingerprint. The actual file, it can be copied 1,000,000 times, stored all over the place, but those are just mirrors. The real reference point, the truth, is the fingerprint, and that never, ever changes.
Okay, so this leads us to the most kind of mind-bending consequence of this whole system. Because when data has a permanent, provable fingerprint, some of the things we just accept as normal in the digital world, they become literally impossible.
Just look at this. You have your original data, and it gets fingerprint A. Simple enough. But now say you go in and change just one single byte. That's like changing one letter in a 1,000-page book. The fingerprint doesn't just get a little update. No way. It becomes something totally different, fingerprint B. Mathematically, it is now a completely new and separate piece of data. There is no way to hide that change.
And the power this gives you is just, it's enormous. It means no more quiet little edits to a document without you knowing. No more wondering if you have the actual final version of a file. The chain of custody, its history, it can't be secretly broken. What you upload is what exists, period. And the best part, anyone with that fingerprint can check it and prove it for themselves.
So when you put all these pieces together, you realize this isn't just about a new feature or some new product. It's a fundamental shift in how we even build trust online. You're not being asked to trust a person or a company logo. You're able to trust the very design of the system itself.
And that really is the ultimate takeaway here. Instead of having to rely on company promises or brand reputations or marketing slogans, trust is literally built right into the architecture. It's guaranteed by math, not by marketing.
Which, leaves us with this huge, fascinating question to think about. When digital information is truly permanent and verifiable, what becomes possible? Think about legal contracts, scientific research, historical archives, even art. What changes? What new things can we build in a world where our digital life can finally be permanent and provable by anyone?